All right, this lesson comes from Chapter 9, Section 6 in my student's textbook, and it's about the quadratic formula. I'm going to break this lesson up into two parts. So part one, I'm just going to introduce the quadratic formula and show you how to use it. So just as a reminder, the standard form of a quadratic equation is this: ax squared plus bx plus c equals 0. And also just a quick review of the other methods that we've gone over for solving a quadratic equation. You can watch the previous videos if you want to learn about any of these. So first one is graphing. Graphing is the least useful method. So I would say you only want to use graphing if you have a graphing calculator, because then you can just type in the equation, look at the graph, and remember the solutions are the x-intercepts. So that's what you're looking for. The other method is square roots, and you want to use this if the equation has no x term in it. So if there's not an x term, then this is a good method to use. The next method is factoring, and you want to use factoring if you can easily factor the equation. So if you look at the equation and you say, oh, I could factor that pretty easily, then use the factoring method. The next one is completing the square. And so completing the square, you want to use this if the coefficient of x squared is 1 and you can't easily factor the equation. So if the coefficient is 1 and you can easily factor it, then use factoring. So completing the square, you want to use if the coefficient of x squared is 1 and you cannot easily factor the equation. And then what we're going to go over today is called the quadratic equation. And you want to use this if the equation cannot be factored easily or at all. So all quadratic formulas can be factored using the quadratic equation. Not all of them can be factored using these other methods. So the quadratic equation always works. So what is the quadratic equation? So here it is in the box. This is the quadratic equation. Again, remember when we're looking for solutions to a quadratic, what we're looking for are the x-intercepts. And that's what this equation will give us. So this equation works if you have ax squared plus bx plus c equals 0 and a is not equal to 0. So that just means you've got to have this squared term here. Now the b could be 0, the c could be 0, but you got to have this squared term. All right, so let's look at some examples of using this. Also, just real quick, this plus minus here, that's because there's square root. Remember, when you take the square root, you get two answers, a positive answer and a negative answer. So the square root of 9, for instance, is positive 3 and negative 3. All right, so let's look at our first example. So I've got the quadratic formula up here in the right corner. The first thing you want to do is put this in standard form. So ax squared plus bx plus c equals 0. So I'm just going to simply subtract 2x from both sides. And then when I get it in standard form, I'll have this. X squared minus 2x minus 8 equals 0. So now you can see here's my a value is 1, my b value is negative 2, and my c value is negative 8. So now to find the solutions, all I need to do is plug these values into the quadratic formula, make sure I follow PEMDAS, work this out, and it'll give me the solutions. All right, so here's my quadratic formula. Negative b is negative 2, so negative 2 would be positive. Negative sign really means the opposite of, so this is saying the opposite of b. So what's the opposite of negative 2? Positive. That's 2 plus or minus the square root of b squared, so again, b is negative 2, so negative 2 squared, minus 4 times the a value, which is 1, times the c value, which is negative 8. So all I did was plug in a, b, and c into this formula. And then that whole thing is divided by 2 times a And so now we're just going to go through this and do PEMDAS. So we're going to work out what's under the square root here using PEMDAS. That means we're going to do the exponents, do the multiplication, and then do the subtraction. So let's go ahead and get started on that. So now I have 2 plus or minus the square root. So I'm going to go ahead and do negative 2 would be positive 4. Subtract will be the last piece I do. I can go ahead and do this multiplication. So I have negative 4 times 1 times negative 8. It's going to give me positive 32. And then that's all divided by 2. Okay, so I did negative 2 times negative 2. That gave me the 4. I did the negative 4 times 1 times negative 8. That gave me the positive 32 here. Okay, so let's go ahead and add the 4 and the 32 together. So that's going to give me 36. So here's what I'm going to do. Trying to decide whether it's up here or not. Let's do this. So we're going to split this because it's a plus and a minus here. So one of my solutions is going to be 2 plus the square root of 36 over 2. My other answer will be 2 minus the square root of 36 over 2. Okay, so I added the 4 and the 32 together to get 36. I went ahead and split this up. This is 2 plus that and 2 minus that. So square root of 36 is 6. So I have 2 plus 6 is 8, and 8 divided by 2 is 4. So there's one of my solutions. My next solution, I'm going to do 2 minus 6. So 2 minus 6 would be negative 4 divided by 2 would be negative 2. All right, so there's my solutions using the quadratic equation. Again, what that means is this graph, remember, the graph is a parabola like this, right? This graph crosses the x-axis at positive 4 and negative 2. It's the x-intercepts. You can plug these values in, and so if you plug in 4 squared minus 2 times 4 minus 8 is going to equal 0, and the same thing for negative. Right, so let's look at another example. Again, the first thing we need to do is write this in standard form. So I'm going to add 4 to both sides. Right? So that's going to give me negative 3x squared minus 11x plus 4, because I added 4 to both sides, equals 0. So here's my a value is negative 3. My b value is negative 11. My c value is 4. So now we just plug those in to the quadratic equation. So again, negative b, the opposite of negative 11 would be positive 11 plus or minus the square root of b squared, so that's negative 11 squared, minus 4 times the a value, which is negative 3, times the c value, which is positive 4. And then that's divided by 2 times a, which is negative 3. And now we just do PEMDAS, order of operations. All right, so I'm going to do negative 11 times negative 11, and then I'm going to do negative 4 times negative 3 times 4, and I'll go ahead and multiply the 2 times negative 3. And that's going to leave me with 11 plus or minus the square root of 121 plus 4 times 3 is 12, times 4 is 48, and that's over negative 6 again, it's just an exercise in order of operations. So it means be careful. Take your time. Go through it step by step. So I'm going to add the 121 and the 48 together, and then I'm going to split this apart. Right. So these are going to add to 169. So now I have x equals 11 plus the square root of 169 divided by -6, or x equals 11 minus the square root of 169 divided by -6. Okay, so the square root of 169 is 13. So 11 plus 13 is 24. 24 divided by -6 is -4. There's my first solution. The next one, 11 minus 13 is -2. So I have x equals -2 over -6. And that can simplify to 1/3. All right, and go ahead, leave that as a fraction. You know, if you have the choice, you should always just leave your answers as fractions instead of changing them into decimals. So x equals -4 or x equals +1/3. All right, let's look at one that's not quite as nice as that one. So this has got decimals in here. And the instructions now, it says round your answer to the nearest hundredth. So the reason here is because we're not going to be dealing with perfect squares. So when we take the square root, we're going to end up with long decimal numbers. All right, so again, here's my A value. This one's already in standard form. And there's my C value. So my A is -400ths. And my B value is +8400ths. And my C value is 2. So now we're going to just plug those in. I'm going to switch my pen real quick, something a little thinner. So -b, so that would be -8400ths, plus or minus the square root. So it's going to be pretty long. The square root of b squared, so 8400ths squared minus 4 times the a value, which is -400ths, times the c value, which is 2. And then that whole thing is divided by 2 times a, so that's 2 times -0.044400ths. And same as before, you know, hopefully you're using a calculator to do this, because otherwise this would not be fun at all. So we're going to do the same thing. We're going to do 2 dots on this. So -8400ths plus or minus square root 8400 times 8400. There we go. Comes out to this. Now it says round your answer to the nearest hundredth. So don't do any rounding until you get down to the very end. Common mistake I see. When it asks you to round your answer, it's saying to round your answer. So to get as much precision as you can, you don't want to round the intermediate stuff. So 8400 times 8400 is this. And then if you multiply these together, you get 0.32. And then that's divided by -0.08. All right. So I'm going to add 0.7056 and 0.32 together and split this apart. Again, same thing that we've been doing. It's just that this isn't quite as Nice. I don't know if that's the right word, but sounds good. Plus the square root of 1.0256 divided by negative 0.08, or x is equal to negative 8400 minus the square root of 1.0256, and then that's divided by negative 0.08. All right, so again, we didn't do any rounding yet. This is the part where we're going to round. And so here's how you want to do this. In your calculator, you want to put in 1.0256 and take the square root of that, and then subtract the 8400, and then divide by the negative 0.08. So take the square root of this, subtract the 8400, and divide by the negative 800. That'll allow you to get as much precision as possible. And then that answer you're going to get, you're going to have to round, in this case, to the nearest hundredth. And so when we do that, we should end up with negative 2.16. And so similarly over here, so here's how I did this. I know that negative minus a number, you're going to have to add those together. So I took the square root of 1.0256. I added the 8400s to it, and then you can make that negative, and then divide by negative 0.08, and negative divided by negative to give you a positive. So this comes out to 23 and 1600 after you round it. All right. So I got one more example for you. So this one's not in standard notation, so let's subtract 4 from both sides and get it in standard notation. 3x squared plus 5x minus 4 equals 0. And this one says round your answer to the nearest hundredth. So guess what? Although our a, b, and c values are not decimals, we end up with something that's not a perfect square again. So we're going to have to round our answer. So here's my a value, my b value, and my c value. So we just plug those into the quadratic formula. The negative b, so that would be negative 5 plus or minus the square root of b squared, so 5 squared, minus 4 times the a value, which is 3, times the c value, negative 4. And then that's all over 2 times a, so 2 times 3. All right, and now we're just going to do order of operations. Let PEMDAS guide us along the way. So I have negative 5 plus or minus the square root of 5 squared is 25 plus 4 times 3 is 12, times 4 is 48, and then that's all divided by 6. And so when you add 25 and 48 together, you're going to get 73. And 73 is not a perfect square, so that's why we're going to have to round our answer here. So let's go ahead and break this into the two pieces. So the first piece I have is negative 5 plus the square root of 73 divided by 6. And my other solution comes from x equals negative 5 minus the square root of 73 divided by 6. So again, to do this with precision, what I did is I did square root of 73, I subtracted 5, and then I divided by 6. And then I rounded that answer to the nearest hundredth. And I got x equals 59 hundredths. Similarly, over here, I did the square root of 73, and I added 5 to it, and then I made that negative, and then divided by 6. So that comes out to negative 2 and 26 hundredths. All right, so I hope you found this useful. If so, please give it a like and subscribe. Until next time.